Number 21 says that we have the graph of a second derivative. It's asking where does the related function have an inflection point. Remember, inflection points occur when there's a shift in the sign of the second derivative. The second derivative shifts from positive to negative at A, so there's a change in concavity at A from concave up to concave down. And once again, there's a shift in concavity at 0 where it goes from concave down to concave up. Don't allow yourself to think about B because it goes from concave up to concave up. For a moment it looks like it might become concave down at B, but that's not what happens. And so there are only two inflection points. They happen at A and at 0. So the letter A is the answer for 21. Number 22 is one that some are challenged by. You know, the derivative is a line. It looks like a line. They tell us it's a line. It's a line that has a slope of -6 and a y-intercept of +6. So there is the derivative. Now the antiderivative, you know, to get f, we need to take the antiderivative or integral of this -6x plus 6. And if we do that, we get -6x squared over 2 plus a 6x plus a c. Now that reduces to -3x squared plus 6x plus c. We're told here if 0 goes in the function, 5 goes out, so there's an implication here that c equals 5. So if c is in fact 5, we can now go through and say, if we put 1 in this function, if f of x is indeed -3x squared plus 6x plus 5, we can put in our 1 and make a calculation. So we get -3 out plus a 6 plus a 5. That's 11 minus 3 or 8. So letter D is the answer to number 22. Number 23 is the fundamental theorem of calculus. You're taking the derivative of an integral, and that puts you right back where you started. I think most people wouldn't have a problem if the original were written this way, 0 not to x squared but 0 to u. In other words, if there was a substitution, you would tell me that this particular evaluation would be the sine of u cubed. But you know, we've taken and made a substitution here for u. We've allowed u to equal x squared. And of course, du would equal 2x dx, or du dx would equal 2x. So for our problem, we have to take the du out, or the u out, and put in its place the x squared. So we have to do that in both places. So x squared ends up being cubed down there. And we have to take our du out, and well, we're going to make a substitution with du dx, right, to get the d dx in that they had originally. So that means we have to take our answer and multiply it by a 2x. So to finish this off, this is going to be a 2x sine of x to the 6th. So E is the answer to number 23. Number 24, we're given a function, and the question is, which of the following is tangent to it where x equals -1? Well, let's find the point on the function at -1, and won't that be a -4 plus a 5 plus a 3? And 8 minus 4, of course, is 4. So our point is at -1, 4. The derivative for the function would equal 12x squared minus 5. To find the derivative at -1, we'll get 12 minus 5, which is equal to 7. So isn't our slope 7? If our derivative is 7, our slope is 7. So we have a slope and we have a point, and we'll take our point-slope formula, right, and bring this together and say, well, y minus the one y we know equals m, our slope, times the quantity x minus the one x that I know, and the x that I know is a -1, so it's going to be x minus a -1. So it'll look like that. Now let's clean it up. Y equals 7x plus 7, bring the 4 over, or y equals 7x plus 11. So it seems that C is the solution. And finally, number 25 for this group. 25 says a particle is moving along, and we want to figure out when it's at rest. Well, this is position, x of t. Velocity is the first derivative, so that would be 8t, excuse me. Velocity equals 2 times 3 is 6t squared, minus, won't it be 42t plus a 72. If we factor a 6 out of that, and you'll see why I'm factoring in a moment, taking a 6 out front, won't we get 6t squared minus 7t? 6 from out of a -42 will leave us with a 7, and then 6 out of 72 is a 12. Now, if something is at rest, it means its velocity is 0. So factoring further, wouldn't we have t minus 4 and t minus 3? So that would factor it perfectly, and the zeros of this factored velocity function would suggest that the zeros are at 4 and 3. And so in our answers choices, it seems E is our answer for 25. And that's it for this group.